Hello and welcome to TN Academy. Today we are given a question where a botanist is conducting an experiment where they are studying the growth of plants. Now the height of plants are measured on 7 different days, and the following table down below shows the number of days D that the experiment has been running and the average height in centimeters of the plants on each of those days. Okay? Now we can see we have days on the top, which will be our x value, and the average height of these plants with those corresponding days, which will be our y value. Now for our first question, the question asks the regression line of h on D for this data can be written in the form of h is equal to AD plus B. Now we are asked to find the value of A and B. So one thing to start that we can see from this equation is that h is equal to AD plus B is very similar to y equals mx plus b. Now we don't want to mistake this for a simple straight line since we are dealing with a regression line. So to calculate our slope, we have to do something slightly different. Yes, for this question, to calculate the slope of our regression line, we must divide the standard deviation of the y values by the standard deviation of the x values. Now, to calculate standard deviation, we use the two equations below, okay, where the standard deviation is equal to the sum of all our x values less or minus the mean of our x values, and we have to do the same for the y values. So in this case, for the standard deviation of our x values, it will be the sum of the difference of all our x values and the corresponding mean divided by our sample size, which is n. We calculate our mean by taking the sum of all our x values and dividing them by our sample size. Now we'll try this out just so you get an idea of what it is that we have to do. So moving forward, we're starting with our x values and we have to first find our mean for our x values. Now to do this, we first in the numerator, we find the sum of all our x values. And so we will get 2 plus 5 plus 13 plus 24 and so on, plus 33 plus 37 plus 42. And this will all be divided by our sample size. And since we have 7 days worth of values, or 7 values, that will be 7. Now, if we input this into our calculator, you will find that you get 156 over 7, which simplifies to 22.2857 and some more numbers. It's always good to keep more digits so you get a more exact answer. But now, to calculate our standard deviation, we will now calculate the sum of all of our individual x values minus our mean value that we've just found squared divided by n. Okay? Now, to calculate our standard deviation for our x values, we will first put in our root and have our first x value minus our newly found mean value, and we will square that so that even though this value will come out to be negative, that negative will not matter. And we do the same with our 5 minus 22.2857, continue with 13 and square it, and we continue all the way with 33 and 37 as well, on to 42 minus 22.2857 squared, and we divide it all by our sample size. Now when we calculate this, we will get the following here. So we have the root of negative 20.2857 squared plus negative 17.2857 squared plus negative 9.2857 squared plus 1.7143 squared plus 10.7143 squared plus 14.7143 squared plus 19.7143 squared, all of which is divided by 7. So now we will square all our values and take their sum to find our numerator. Now, after calculating for our numerator, we should find it to be 1,519.428571 over 7. So we will divide this first to find that our answer will be the square root of 217.061, and then take the square root of our answer, which is 14.73299781, but we can round that to be 14.733, and we've rounded the 2 up here. Now we will do the same thing, making sure to write down our standard deviation of our x value, but we will now calculate the standard deviation, yes, of our y value, using the same steps, but instead of using our x values in the table, we will substitute our y values, and find the mean for our y values, and then continue on to find the mean for our variance as we have just here. Okay? So now calculating for the mean of our y values, where y is equal to h, yes, and is divided by n, we will have 10 plus 16 plus 30 plus 59 plus 76 plus 79 plus 82 divided by 7. And when we calculate this, 30 plus 59 plus 76 plus 79 plus 82, we will get 352, and that will be divided by 7, which gives us 50.28. We'll round to 3 digits. I have 2857, so I will round my 5 to 6. Okay, and now we will use this standard deviation formula to find the standard deviation of our y value. Okay, so you write out the formula, and it should look something like this. Please pause the video as it is somewhat squished, but we have 10 minus our mean, and then 16 minus our mean, all of which is of course squared, then 30 minus our mean, then 59 minus our mean, then 76 minus the mean, then 79 minus our mean, all of which, again, just to reiterate, are squared, and we finish our sequence off with 82 minus our mean, and where our mean is 50.286, and it's all divided by 7, and then when we calculate this value, we should find that it comes out to be the square root of 825.3469, which then comes out to be 28.729 after we round up. And now, after I mentioned before, to find the slope, let's call the slope m. It is the standard deviation of y divided by the standard deviation of x, that is a sigma, just so you know, which will be 28.729 divided by 14.733. And then we could plug this into our calculator. to find that our slope for this line is about 1.9499, which we can round up to be 1.95. Okay, so now for our equation, we have values for both H and for B. Sorry, we have a value for H and D. We have values, multiple values for H and D. That's what I mean to say. And so we can select two of the values so that we can solve for B, since we already have A, and now all we need to solve for is B. So I'm going to select the values for D of 2 and the value of H, I'm going to select 10. Okay, I'll just write this out so that it's clear. So we will let D equal to 2, and then our corresponding H value will be 10. And we've calculated A, which is equal to 1.95. Then if we rearrange our equation to solve for B, B will be equal to H minus A times D. So then when we substitute our values into this, we will get B is equal to 10 minus 1.95 times 2, which is 10 minus 3.9, which just comes out to B. B is equal to 6.1 000, and the zeros continue on. But our answer is that A is 1.95 and that B is 6.1. Now, for our second question, we are asked to write down the values of the Pearson's product moment correlation coefficient. So, to find the Pearson's moment correlation coefficient, we have to use a specific equation. Now, for this equation, we must take the sum of our x values, a particular x value, I, where I is an integer between 1 and 7, and a particular x value minus the mean of x, and multiply that by the corresponding y value minus the mean of y, and divide it by the square root of, again, the sum of all our x values minus their mean squared, multiplied by the corresponding y value minus their mean squared. Now, we can recall the mean of x and the mean of y that we previously calculated, so we don't have to do the extra work. And the equation should look something like the following in an expanded form, where we'd have x1 minus the mean of x times y1 minus the mean of y, plus x2 minus the mean of x times y2 minus the mean of y, plus, and we go all the way on to x7 minus the mean of x times y7 minus the mean of y. And as you can see on the bottom, we are doing the same thing with y1, but in this case, for the denominator, we are squaring the value, and we're doing the same with the y. And then we add the second x minus the mean, and we square that, and do the same with the y, and we go all the way onto the 7th value. Now, when we will substitute actual values for this into our equation, you should find that it comes out to be something like the following. Please cross-check, or pause the video rather, to cross-check that your values in the numerator have come out to be more or less the same. I've rounded some of the values in the denominator here for the sake of fitting them all into this video, but your values should still closely approximate mine. I would not recommend that you round them, just so you can get the most exact answer. And then when you put everything in your calculator, you should find that our correlation coefficient comes out to be 0.9911. Okay? Now, for our final question, we are asked to use our regression line to estimate the average height of the plants when the experiment has been running for 20 days. So we can solve this by using the values we previously calculated, where A is equal to 1.95 and B is equal to 6.1, maybe 1.1. And our equation, we are looking for height, which is h, when the experiment has been running for 20 days, so d is equal to 20. So we say that h is equal to AD plus B, right? So we say 1.95 times D, which is 20, plus B, which is 6.1. And we plug this into our calculator, and we should find that at this day, the approximate or the average height of the trees will be 45.1 centimeters. And that is all for this question.